Alright, so Professor Jim Schultz here for my Finance 680, 670, or could be Finance 311 students. I thought I would take a few minutes here and throw together a few basic time value of money problems to kind of help you with your studies in learning this concept, and even more importantly, possibly learning how to utilize your calculator to solve some of these basic problems. So let's start with this first problem. You will be receiving $1,000 in 12 years. So at an 8% discount rate, how much is this worth to you today? Now I already have this filled in, but this line right here kind of tips you off to the fact that you are looking for a present value. Okay, and then I would draw a timeline. I don't really feel like doing it with the computer, but I would certainly suggest and advise all of you to include a timeline along with your work so that when I'm grading it, I can clearly see what you're trying to do. So for this one's pretty straightforward, right? We've got our inputs, $1,000. This is going to be 8, and remember that it has to be a percent, not a decimal. There is no payment, so I'm going to enter that as 0, and then n is 12. And now I'm going to work this out along with you all. And remember, you want to press the number and then the button. So 1,000, future value. Your calculator should say future value is equal to 1,000. 8i, 0 payment, 12n. You can move right from one to the next. Compute PV. And you should get minus 397.11. Now we remember that that's not truly a minus, that's not truly a negative number. We have to take the absolute value of that. It's only negative because we made our future value positive. Again, if you don't believe me, redo this problem, make this negative, this will come out as positive. So here is the correct answer, $397.11. So let's move on to the second problem. The second problem is a little bit different. Now we're going to work with an annuity. And if you remember, an annuity is an equal fixed payment over time. And so you have an annuity that will last 5 years and pay you $425 per year. If the interest rate is 6.5%, then how much will this annuity be worth at the end of the 5th year? So now, just by the wording in the problem, that is what you're looking for. You're looking for your future value. All right. Now this might be helpful to put a timeline up, but again, I'm not, just for in the interest of time. But if you had a timeline, you would essentially have 5 different tick marks, and they would each have $425 sitting on each tick mark. The first tick mark, though, that would be 0, at time equals 0, meaning now. There's nothing happening now. Nothing is taking place now. So this is going to be a 0. And then from here, you simply fill in the other inputs. So this is 6.5. This one is 425. And that is 5. And again, you just put these into your calculator in any order. 0 PV. Don't forget to enter 0 PV. Don't skip over it. PV equals 0. 6.5 is I. 425 is payment. 5 is N. Compute future value. I got $2,419.80. So $2,419.80. So that is the answer to number 2. So now number 3, this one's a little bit different because you can see the problem tells you that you invested $4,014 3 years ago, and now this money is worth $48.77. So what rate of return did you earn on your investment? So here we're actually looking for I. Now I picked this problem on purpose because it's going to kind of illustrate a couple different things. The first thing is this. Normally when you're setting up a problem, your PV equates to now, like right now, present day, current environment. Well, for this problem, the best way to set this one up, and it may not be the only way, but I'm actually going to put my PV as 3 years ago and my future value as now, right? So my PV here is going to be 4014 and my FV is going to be 4877, and the time between those 2 points is 3 years. And then obviously there's no annuity, so there's no payment, right? So this is an example of kind of what I mentioned in class, in that your PV is not always today. It usually is today, but not always. Sometimes you have to be a little mentally flexible and move that guy around when your circumstances change. So that's the first reason why I picked this problem. The second reason why I picked this problem is this. Remember, your PV and your FV must have opposite signs. So I'm going to make the PV negative, although it does not matter which one is negative. You will get the same answer. So PV is negative, FV 0 payment, 3N, compute I. I got we'll go with 6.71% to the nearest hundredth. Now, go ahead and do what I'm going to say next. Work it out with me. Suppose you forgot to make one of these negative. Let's put them both in as positive and see what happens. So 4014 PV, 4877 FV, 0 payment, 3N. Compute I. Your calculator should say, it should say to you error 5. So what does that mean? That basically is your calculator bailing you out, saying, hey, you made a mistake, you need to make one of those negative, here's an error message to give you a second chance. Essentially, there's nothing wrong with your calculator is not broken. This is to this point it has been a user error, and so but it's helpful because it's telling you that you made an error so you can rework the problem and get the right answer. Now unfortunately, not every scenario is like this, in the sense that sometimes when you forget the sign conventions, it will not give you an error. It will give you some number, and you're going to think that number is correct. And so be very careful. I picked this problem to show you that if you get an error message, it's probably a sign convention issue. So if you correct that, you will be well on your way to solving the problem correctly.